the importance of assessing subfloors. In this module, we will look at the importance of assessing a subfloor in maintaining the integrity of the whole floor. The subfloor is beneath a floor, and unless it is laid correctly, the floor won't perform to its optimum structural ability and will have a reduced service life. There are many different types of subfloor that timber floors can be laid over, and therefore different aspects that need to be assessed. We'll discuss three key areas: why it is important to assess subfloors, assessing timber subfloors, and assessing concrete subfloors. Most floor failures are the result of laying floorboards over an unsuitable subfloor owing to an inadequate assessment. The first image shows a solid timber floor under which the particle board subfloor has buckled off the joists. The second image shows a floor that was not adequately protected from moisture in the concrete slab beneath it. The third image shows what is known as tenting and cupping, again resulting from a wet subfloor. The fourth image shows a bamboo floor that is also cupped from moisture beneath. It is important to realise that all these could have been avoided with a proper subfloor assessment. The first type of subfloor that we'll look at is timber. A timber subfloor means that the flooring material has been laid over plywood, particle board, or straight over timber joists in the case of some solid strip floors. In constructing a timber-based subfloor, there are four important things to consider. Avoid laying flooring over a wet subfloor space. Ensure adequate ventilation of the subfloor. Address poor subfloor conditions, and timber sheet subfloors need adequate fixing to joists. The images show evidence of inadequate ventilation, which is particularly damaging to all floor types when combined with seepage into enclosed subfloor spaces. The most important piece of information there is when laying a floor is to never lay it over a wet subfloor space. These photos show the repercussions of a poorly ventilated subfloor that has been exposed to moisture. Problems like seepage and ventilation need to be solved for the floor to work and last. Once again, we see the effects of laying over a wet subfloor. Seepage may sometimes only affect a small part of the subfloor, but it is a continual source of moisture and will eventually ruin the subfloor. In these examples, a reputable product was used to waterproof the particle board subfloor, but due to raised moisture levels from lack of ventilation, the floor was damaged. It is very important to ensure that there is adequate ventilation to enclosed subfloor spaces. Subfloor ventilation is not just a timber floor requirement, but it is a requirement of the National Construction Code. Yet still, from time to time, we see new dwellings or extensions that do not meet even the minimum under the code. The NCC code requires a ventilation space of 7,500 square millimetres per square metre of wall, which may sound like a lot, but amounts to only a 75mm by 100mm open space. The general rule of thumb is to ensure that half a house brick worth of free ventilation space is left for every length of perimeter wall. It's good practice to make sure that the ground immediately surrounding a dwelling is sloping away from the walls to ensure that water doesn't pool along external walls. Stray from these requirements too much and the consequences will be swift. There are a range of scenarios in which subfloor conditions may not be suitable for laying flooring. If the flooring contractor raises concerns over the subfloor space conditions, then it is up to the builder or owner to correct these conditions prior to the timber floor being laid. Some important aspects to note are subfloor space humidity should be similar to that of the external humidity. Relative humidity meters are cheap and accessible and are critical to assessing humidity levels. If your subfloor ventilation is insufficient, consider more vents or even mechanical ventilation. And with high humidity due to seepage issues, consider enclosed drainage systems and use of black plastic membrane over damp, but not wet soil. The before and after shots here show a subfloor space where the ground level is below the external ground level. As a consequence, the soil beneath the dwelling remained very damp and sticky for much of the year. The owner had installed a mechanical ventilation system, but initially had not addressed the damp soil. The ventilation system made little difference by itself. However, once the level of the subfloor was raised with crusher dust and a water membrane was laid to provide a moisture barrier, the floor that had exhibited problems for over 2 years quickly recovered. Consideration is also needed when fixing sheet subfloors to joists. It is necessary to ensure that if high-density solid timber is fixed to particle board or plywood subfloors, that the subfloor is adequately fixed to the joists. Timber flooring that is adhesively fixed to the sheet subfloor creates a super strong panel. Composite panels like this that don't allow for expansion mean that the panels are prone to arching, as shown in the diagram. Industry publications document particle board and plywood subfloor fixing requirements for high-density solid timber flooring. The information states that in moderately humid locations, some nail and adhesive fixed sheet flooring has buckled off the joists, even when fixed in accordance with the relevant nailing requirements of Australian standards. Screw fixing to the joists, as also often used, provides a more robust fixing. Note that insufficient adhesive, insufficient fixings across the width of sheets, and fixings missing joists often contribute to these problems. Let's move on to concrete subfloors and examine the requirements to note. Many timber floor types are laid over a concrete subfloor. There are 4 important aspects requiring consideration: how dry the slab is, how flat the slab is, how clean the slab is, and how sound the slab is. The last 2 points are mainly applicable only when direct adhesive fixing to a slab. Timber floors of all types need to be guarded from potential slab moisture. A slab needs to be thoroughly assessed before laying a floor to ensure it's dry enough for laying timber. If the slab contains more moisture than desired, another means of protection, like a moisture barrier, may be suitable. The only way to determine slab moisture is by undertaking a test. The photos here show 3 techniques for assessing a slab's moisture content. The impedance meter in the first photo measures the moisture content in the upper 20 millimeters of the slabs. The second photo shows an in-slab relative humidity meter assessing an air pocket about 40 millimeters below the surface. The last photo shows an insulated polystyrene chamber assessing the moisture content from above the slab. In Australia, the first 2 methods are generally more common. An often raised question is whether a moisture assessment is necessary if you already plan to use a moisture barrier. Moisture assessments should be made in all circumstances to ensure particularly moist areas are treated with the appropriate thickness of builder's plastic. Now let's consider some potential slab moisture problems that can occur. In the example shown here, some efflorescence was discovered on a 3-year-old slab along the perimeter of a wall. A moisture reading away from this efflorescence came back with a reading of 2%, meaning a dry slab. Moisture content over the efflorescence read much higher at 5%. This presents a moisture content too high to lay a timber floor. The second photo shows the effects of laying a timber floor on an area of a slab that has a high moisture content. The area along the wall came back with a higher moisture reading and has consequently buckled the parquet flooring. A common myth is that old slabs are dry slabs, but there are many elements that can affect slab moisture. Does the slab have a black plastic membrane beneath it? How well was the concrete placed? Was water added to the mix on site, affecting the water-cement ratio? All these aspects, along with groundwater, can influence ongoing slab moisture. In this series of photos, we examine an original 8-year-old floor that was replaced due to water damage from a leaky fridge. The original floor was laid over plywood with a black plastic membrane and had performed well before the leak. The replacement floor was laid without a moisture barrier membrane beneath the plywood. An oven dry test of the moisture content of the new flooring in the kitchen showed a very high moisture content due to the lack of a plastic barrier. The old floor, which still remained in the living area, came back just as expected, with a great moisture reading of 11%. A dramatic difference which can be solely attributed to the water barrier. It's interesting to note that the photo of the slab with high moisture content doesn't have any pools of water. It's a slow moisture release that causes this problem, which is why it can go unnoticed. As we said, this old dry slab is not an old dry slab. When constructing your floor, you will find that different floor types require different degrees of slab flatness. With adhesive fixed floors, this generally relates to what the adhesive manufacturer requires. With floating floors, it is the flooring product manufacturer's requirements that needs to be followed. Requirements are quite product specific. Note also that some floating floors are very competitively priced and slab preparation requirements can be costly in comparison. To assess slab flatness, a straight edge and perhaps a taper gauge can be used to determine flatness. Some contractors mark in red for remove the hump and mark in green for a low spot to map out the highs and lows in the floor. It is also important to take into consideration the board direction. Checking perpendicular to the run of the boards is very important. With floors that are adhesive fixed, there is generally to be no more than 3 mm under a 3 metre straight edge, or with floors on plywood, no more than 3 mm under a 1.5 metre straight edge. For floated floors, the gap is often to be no more than 2 mm or 3 mm per metre, depending on the product. When direct adhesive fixing to a slab, it is also necessary to assess both for slab integrity and for contamination. With this, we need to consider contaminants on the concrete, including curing compounds, paint and adhesives, and rain damage, latency and slab integrity, depending on product and installation method. In the first photo, there's a steel ruler that was able to gouge the surface of the concrete to a depth of a few millimetres. The concrete dust piled up at the bottom of the photo. Consequently, the adhesive fixed floor delaminated. The second photo shows how a slab sealer used to cure the concrete acted as a release agent for the adhesive. As a result, the whole parquetry floor delaminated from the slab. It is very important to make sure the slab is properly prepared for hosting an adhesive. In short, if the foundations of a building are fundamentally wrong, then the building will not stand. If the subfloors beneath a timber floor are not correct, the floor will simply not perform. Once a floor is laid, the subfloor is no longer seen, but it is such an important part of a successful installation that proper steps are taken. Some key points concerning subfloor assessment are: 1. Many of the floors that fail are due to inadequate subfloor assessment, which provides a useless foundation for laying a floor. 2. Subfloor spaces need to be dry before laying a floor and remain dry after floor installation. Correct conditions and ventilation are essential. 3. When laying a sheet subfloor straight onto the joists, robust and accurate fixings are essential to the lifetime of the subfloor. And 4. Concrete slabs need to be assessed for 4 aspects: the slab's flatness and dryness, and when using adhesive, its soundness and cleanliness.